Hi. I have a lot of things to say, so I'm going to talk really fast to keep you awake until the next session. So I'm just a final blocker. So I'm Daniel Stenberg. I've been working in this curl factory since 1998. I actually started working on HTTP already before that, but a long time. Nowadays I work for Wolf SSL, and we do curl stuff with commercial support for curl, basically. So I'm here today to talk a little bit about curl. Curl is an open source project. We do a command line tool called curl, and it's libcurl, which is the library embedded that actually sort of provides the powers. Curl is feature-packed. It can do a lot of things. It's actually, I like this analog of the Swiss Army knife of internet transfers. It can do a lot of things, and we have a lot of tools, and they're all sharp, and you hurt yourself often. But okay, curl is also not just me, right? We're a lot of people. We're actually 2,000 people, a little bit over, who have contributed to curl with writing docs, filing bug reports, filing code, and broad ideas. And we're about 730 authors who have actually written code to curl up to date. We're adding several hundred contributors per year and a few hundred authors per year during the recent years. We're also roughly 150 authors per year, and we're about 12 people who actually do more than 10 things in a single year. And we're me doing that every year, like forever. Isn't it ever done? My wife used to ask me. No, it's not. So why is curl popular? Why did it work? Or why is it everywhere? Right? I happen to stumble upon this and do this at the right time. I think. I mean, I started this 1996, and at that time we had 250,000 servers on the web. Today we have 2 billion. There are like 10,000 more servers. So I sort of, it was a wave and I could surf on it. And it was open source from the beginning. Everyone could participate and do it together, and we could build a really good tool. And it's portable. It's been installed and run on 71 different operating systems. It basically runs everywhere. And it is backwards compatible. If you run something today, you can basically expect that you can run that command line tomorrow, and in 10 years, and in 20 years, it's going to run the same way. It's stable, and it's there. It's, you know, it's the hammer in your toolbox. It's there. You can do whatever you want with it. It's not going to break. So it's everywhere. It is installed in Mac OS since a long time. It's now in Windows 10. It's in every Linux server. It's in every BSD. It's everywhere. Blah blah blah. And you build it from source if you don't have it. So it's yeah, you have curl. Right? But it's also in a lot of different flavors, because we have literally millions of different build combinations. And it's really crazy, you can't really test them all. But so we have a bunch of different dependencies. You can build curl with up to 30 different dependencies in different combinations, not all of them, but in various random combinations. And we do frequent releases. So right now I'm working on release number 186. We're going to release it in 3 weeks, I think. So yeah, a lot of releases. So basically, there's rarely two curl installations that are the same. Well, if you run Windows 10 and your neighbor does it too, they're actually the same. But if you talk to your neighbor who runs Linux or run Mac, they won't be the same. Pretty much the same, but not identical. So we have different versions, different features, blah, blah, blah. So today I'm going to focus on the tool curl and forget about the libcurl. It's a library underneath. We don't have to care about it. Curl knows a lot of protocols, 24 of them. We care mostly about HTTP today. It features, I actually added command line option 226 the other day. 226, and I'm going to talk about them all today in 24 minutes. But I'm going to stick to HTTPS, and I'm going to stick to a small subset of flags and just sort of run through some fun ones. And just to reiterate, an HTTP, as you know, that's the client, that's the server. We have a request, you know, method pass and blah, 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 and that's how HTTP works, right? Simple. And it's been working like this since pretty much, not exactly the way Tim Berners-Lee made it, but HTTP 1.0 was like this, 1995. So, yeah, it looks like this. request, response, blah, blah, a lot of headers. Okay, that's HTTP. Back to curl. Curl is minimal by default. It only does what it needs to. It doesn't do anything extra. You have to ask for extra things. So it only provides a bunch of basic headers in the request, and it will show the response. There's no fancy functionality unless you ask for it. So it'll do the bare minimum. And you enable stuff, like they're all switches. You enable on and off 226. Not all of them are HTTP related, but you can toggle on and off a lot of different things. And oh yeah, there are long and short options, so you can use -s or -- silent if you want to be more. When you write scripts, it's actually sometimes better to write the long ones, right? So you remember afterwards. But today I'm going to use the short ones because I think people tend to use the short ones when we write like in terminals or just playing around with them. Yeah, 226, they don't all have short options, right? I've actually used up the entire alphabet in uppercase and lowercase. There's one letter left now. So what I'm going to use that for? The uppercase W. And that is not actual command line that you can use. That's a billboard in Silicon Valley from a few years ago. It's completely nonsense, but it's fun. So you do curl, here's a terminal or made up one. Curl and the URL, and actually this is not the URL, as you know, but curl can actually pretend that it is one. Yeah, and that you get the contents back. This is the primary example of the most simple curl command line, right? And you can do, and maybe I should emphasize, you don't specify which method this is, right? I talked about HTTP, you know HTTP, HTTP get is the method to get something. We don't say get here, it'll do get by default. But you can also ask for that -i, lowercase I. And you get the response and the headers and then the body. And you can also then, if you get JSON out of this, you want to show it fancily, curl doesn't show anything. Curl doesn't know about the content. It has no idea what you're getting. JSON or HTML or a JPEG. It has no idea what that is. So you pipe that into a tool that knows about it. JQ, an awesome JSON tool. So you pipe it into that and it'll show it nicely. If you just pipe it to the terminal, you get the random junk that the site sends you. And of course, you continue like that, right? So you do a head request with a capital I, and then you get all the headers, and there's no body, because there's no body when you do a head request. That's just how HTTP works. And as it only does the things you ask for it, right? So it doesn't follow redirects by default. So if you ask for a little resource here, there's a redirect, 302, and there's actually, 302, and there's a location. That's a redirect, right? But curl won't go there. You'll just get that. No body. So you have to ask for the redirect. Follow the redirect, that's the capital L. So, sure. And then it'll follow the redirect, so we get a 200 back instead. And no location here, but no body, because that's still a head in there. Right. We ask for every little thing that we want to add in the request. But we still don't mention which method it's using, right? We don't spell it out. We'll get back to that. So, and of course, if you want to know more about what's happening under the hood here, we add the -v or -- verbose, and we get more information about exactly which IP address, what it's doing TLS-wise, and it will even see the outgoing request, which happens to be HTTP2 here, so it's sort of a lie, but yeah. And we can also, of course, then add custom headers. If we want to send in a magic header, magic disco, then we'll just pass it on. We can also just replace a header. User agent is a common one, right? So if instead we don't want it to know that we're using curl, because someone will just insert a rule, no curl, so we just say that we're disco in the night instead. Or we can just remove the user agent completely, so we just don't have any content on the right side, so that it'll send the request without the user agent, which is also fine. Some servers won't like it, or in this case, you will actually just enter a blank user agent. Fine, fun things to try your servers with. So you can also, of course, send a post. And again, we don't say that there's a post here, because you just send the data. -d, here's the data. My name is Daniel. Send it to the server, and you get a response back, of course. And yeah, in this case, there's actually a body. Might be. Yeah, so, and we post a file, we can just specify the file name instead with a @ sign. And we can also do other fun things, right? Like piping one command into curl and tell curl to use the file from standard input instead. And then we have a data binary option too, so you can send it completely in binary and blah, blah, blah. You can do different things. Right, and in this last case, then you can also specify. Here we add more combinations, right? We specify this extra header too. We say that content type is JSON because we want to send this JSON file and tell the server it's JSON and talk about it. And we can also then put the file, which is not the same as post, but basically very similar. So, capital T to post a file. So, you know, and we can also change the method. We can use a random method string. Here we're doing a put, but we don't call it a put, we call it a swoosh instead. So we use the capital X swoosh command, and we do that, we send it to the example.com file. Very simple. And here's my, we don't use capital X in vain, because that leads to pain. And I will tell you why. Because I'm using this little thing here because I don't know if you know this, but a lot of places on the internet today, they're using curl, showing how you use your API, and here's a curl command line. And they often use this little switch. And I'm the guy there. I'm out here to tell you that's usually not necessary and often done wrong. So if you do like this, you do a post to a site, send whatever data, and here we tell, and we want to emphasize this is a post, because it's not necessary, of course, to do that capital X, because the D already says that. And then we ask it to follow the location in the redirect. That's the capital L. But we asked it to do post, but the redirect doesn't really, it doesn't imply that we're doing post twice. So by this, we're actually breaking a lot of things, because we're telling curl, use this capital X post. Use post even when you do a redirect, but maybe the server doesn't like it. So that's not what we do. So capital X tells it to use that request in all requests, even redirects, which is usually causes a lot of pain. You don't want to do that, so I just have this little picture to just remind you. You usually, you can live your life without using capital X as an option. Just a good trick. And then we add cookies. You heard before, you actually use cookies sometimes in APIs, but sure, cookies aren't just name value pairs. You all know about cookies. You send them from the client, or you get them from the server, you send them back from the client if the URL parts matches. And again, curl doesn't know about cookies unless you ask it to know about cookies. Nice formatting on my slide here. You can. So you tell curl, you can do it like this. Ask curl to enable the cookie engine, and whatever cookie it receives, save it in this file when it receives it. And then we can do the next request, use all the cookies in this file in my next request, so sort of engage the cookie engine. So if we get cookies in the first, we can send them in the second. And usually you can always sort of get and send in the same command line. And then it'll save them in this little file. Easy peasy. Usually that's the way a lot of sites are working, right? So if you want to do a login on a typical website with curl, you do it like this. You just first you ask for the login page. It'll save some cookies for you. Then you log in to the site. Here's my name and my magic password. It'll probably update the cookie. Maybe not. Maybe it will. Usually you would also follow the redirect here, but I've left it out as an exercise for you. And then you'll just get that magic file that you can get when you're logged in, because now you're logged in, the cookie says so. Easy peasy. But today we're using HTTPS all the time, right? And then we have some other fun things, because when you do like this, you want to run your site locally, maybe not on exactly your machine, but maybe in your lab network or whatever. And this doesn't work, right? Because there's a certificate here, and it doesn't match the IP address, and it doesn't match the name, and curl will complain. And then it's very tempting to use -k or --insecure to say ignore the certificate. But that's not really how we want to do it, right? Because that'll certainly leak into production at some point, and you will be sorry, and there will be tears and unhappiness. So we don't really encourage that way. But you can then do like this. You can pass on a host header, right? Tell the HTTP server we actually want this host. It doesn't work with certificates either, so you don't want to do that. So we have this fancy little feature in curl, so you can actually tell curl to use example.com as the real name and expect that to be the certificate, but use this fancy IP address instead, sort of, instead of name resolving like you would, pretend it's this IP address, which is a pretty handy way to connect to your local test machines with the real name. Or you can actually, yeah, right, and then you get everything. The host works, cookies work, the certificate works, everything is just fine and dandy. Or you can actually ask curl to instead use another host name instead of the real host name from the URL. This is, and in this case, it's particularly interesting if you want to connect to one of your 42 machines that are handling the load balancing stuff, perhaps. So you know you have a name for one of them, but you want to use the origin name in the URL. But again, you don't use -k, so I made another little slide for that. So, yeah. Also another option that sort of is used everywhere, far too much. Some other little details. If this isn't enough, and in many times when you're working with curl and everything, it's not enough, right? You're wondering what happens really underneath. What's the request that gets sent out to the server? What happens here? So you add this little option. This is much more verbose than the -v I showed you before. Trace ASCII is an option to say just base. Show me everything that happens in and out from curl, ASCII-fied. So you can get. So here you can see the outgoing request. You ask for the example.com site. You want to send this data as a post. So here's the entire request. So there's the HTTP request. There's some blah, blah, blah about the TLS. Maybe you don't want to see that. And then you can actually see down here how it actually sends the actual post data in the body of the request. And I cut it off here because it shows more. But I just want to, primarily this is good to see the full request because this is an excellent way. When you're using HTTPS, it's TLS anyway, so you can snoop on it that easily. Then you know, what did curl send and what did it receive? Every little byte. And if that isn't enough, there are more options. So you can convert your little curl command line into your own little program. If you think running curl command lines isn't good enough, you can just convert your curl command line into C code. You can compile the code. Well, if you're on Linux, you can just run GCC on that code, and you can run it, and you have your own curl that does exactly what your command line did. You could have a more fancy command line than that one. And the code then looks roughly like this. So it generates the code according to that command line. So if you have a command line that works, you'll get source code that does the same thing. It's actually a pretty convenient way to kickstart your libcurl using application. Right. And if that is not enough, because you want to do something else fancy, you go to your browser and you do something like you log into a site or you click or you watch something, and you want to make sure that you want to be able to do exactly that little thing with curl. So then the browsers invented this copy as curl feature. This is a screenshot from Firefox. Here's Chrome and here's Safari. They all have the copy as curl. And even Edge has it now, since it's based on Chrome now. So all the 4 major browsers have this copy as curl feature. These are old screenshots. I don't think they look exactly like that now. But if you go into the developer tools and you watch network, and you can just go to the little request and do copy as curl, and you do paste, and you'll see a command line like this. Boom. That's copy as curl from Firefox. Not the most easily read or understood command line, but that at least generates a request that is exactly the same thing that Firefox just issued. Many times you want to trim this because maybe you didn't really actually want exactly the same thing, especially if there are cookies involved here. You might not want to send the exact same cookie. And I did the same thing with Chrome as well, and it gave me this even longer blob of text. And if that is not enough, and you want to go even further, I can also recommend, since we're doing everything in HTTPS these days, it's not that easy to see what the browsers and curl are doing under the hood, right? So you enter the SSL Key Log file land. So this is a fun thing to snoop on both your browser or curl and other tools too that supports this fun thing. So Wireshark is your friend in general, right? You want to snoop on the traffic and see what happens. So you set this little environment variable called SSL Key Log file in uppercase to a file name, and you run either your browser and your browser as in Firefox or Chrome. I imagine that Edge also supports this now. And then you fire up Wireshark, and you do this in Wireshark. Oh, sorry. This is how you do it in the curl side first. So you set the environment variable to point down to path, and that's the path basically store all secrets in this file, and you run curl, and it'll do whatever it wants to do, store all those secrets in that little file, and you fire up Wireshark, tell it to read all the secrets from that file, and then you can snoop on the traffic perfectly fine in Wireshark, even though that is full encrypted HTTPS and TLS. And then, of course, you can do the same thing with the browsers if you want to see exactly what kind of requests they are doing. Or analyze even further. This is a screenshot from an HTTP2 debugging session. All the details are there to play with. But sure, HTTP has been with us for a long time, but we're actually trying to change it these days, right? So HTTP 1.0, 96, and then we got 1.1 in, also actually in, no, it shipped in 97, the first one. And but we've become accustomed to what HTTP headers look like, even though in modern HTTP versions, we're actually sort of changing how we're sending stuff over the wire, so they don't actually look the same way, really, anymore. Yeah, the 2 is here, the 3 is coming. But we're still pretending that headers look the same way as they did before. So if you know HTTP headers, and I guess most of you do, you know, name, colon, value. In the curl case, we pretend they're the same one, so they will look the same. There will be name, colon, value, even whatever version you have. And of course, you can fire off curl request by specifying which particular HTTP version you want. Just, do you want to have HTTP 1.0? Do you want 1.1? Do you want HTTP 2? Or do you want HTTP 3? It's just the same thing, and it'll use that version if it can. The HTTP 3 one isn't really there yet, unless you try harder. It's good fun. You should do it. Right, and another little thing that is we've added. So when you've done a project for 22 years, it feels like, yeah, we added this recently, but I'm not sure it was that recent. Maybe it was 10 years ago. so we added this fancy feature. So you can do many things on the same command line if you just specify more URLs. Just add. There's actually no limit to the number of URLs. Basically, your command line probably doesn't support that many, but just fill up URLs. But it'll do the same thing to all these URLs. So you will send this post to all these URLs. Bam, 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 one after another. Maybe you don't want to do that. So then you can actually do this little -- next command, which separates these ones. So in this case, it'll do a post to the first URL and then a get to the second URL on the same command line, which is handy to do that on the same command line sometimes because it'll reuse connections and everything. So to do them on the same command line will be much faster than doing them in 2 separate ones. And it might also be fun to do that when doing cookies and everything. So yeah, you can do all that, and you can actually do a lot more. But yeah, and in the other direction, you can do here's it doing a get first and then a post in the second request. And of course, and again, here you can actually do an unlimited number of these on the same command line. And if the command line is too short because you want to do hundreds or thousands URLs, you put them in a file instead and pass that to -K option. So yeah, all that and a lot more about curl and everything of these command line options, and the other 204 can be read about in this little book that I've written. It's actually available online for free as PDF and web and all sorts of formats, and you can actually buy a printed copy if you insist. Yeah, and you can help to make this better in the future, because it'll never end and it'll keep on improving, and there are a lot of bugs left to fix. And that's it. Thank you.
Really great presentation, Daniel. We all use curl every day, and I think all of us learned something there. We have a couple minutes here. Does anyone want to ask Daniel a question over here?
Hello, Daniel. So first of all, thank you for making curl. My question is about those 22 years. Like, that's something for me unimaginable. I don't know how many of you were building one piece of software for 22 years. Can you tell us a little bit more on the challenges during 22 years building one thing?
Well, I've done other things too. Yeah, that's. I actually have a pretty hard time to explain that, but curl has been my hobby, my spare time project. I created it. It was fun. People liked it. I liked it. It was fun to do it, and it's been my spare time project. So it isn't that I haven't spent all days, right? I spent spare time on this for a very, very long time. I just think it's fun, so why stop? And internet in general and internet transfers and everything it keeps evolving. So to keep up with everything, I have to keep changing curl and improving things. And then I'm sort of introducing bugs all the time, so I have to fix them also. It's just a lot of fun. That's why.
Yeah, good answer. All right, one last one, maybe? All right, well, grab him at the network and are you ready to stay around?
I'll stay around for
a
a
while.
while.
All right,
Yep.
super. Great. Thanks again, Daniel.
Thank you.